Okay, this is a quick tutorial on how to complete a system reliability problem with backups. So let's take a look at a very basic problem. This is something that is pretty frequent in businesses. We have made a promise from our company that we will maintain a 95% quality service level. And in this case, we're talking about ordering a certain product. And but this is a 95% service level. Could be a service such as cleaning carpets or cleaning windows. It could be a delivery service. It could be any number of operations or customer service issues that we promise that our product or our service will reach 95%. And we made that promise because we have 3 different phases that each customer order goes through: the ordering department, the shipment department, and the delivery department. And in our case, all of our departments, our lowest one is 95%. So we felt confident that we could make a promise to our customers that their orders would be at least at 95%. And because of these ratings, we had no question that we would be able to meet that promise, and our customers were confident in ordering with us, and we weren't going to lose business even with the 9% inaccuracy. So why do we still have complaints? We've been receiving a lot of complaints. So let's take a look at this. We have a 96%. So 0.96 in our ordering department, a 0.98 in our shipment department, and a 0.95 in our delivery department. Now let's say we start the day with 100 orders. With 100 orders going through the order department, what's going to be left to go into shipping that's ready to ship, that hasn't failed the ordering process? So we take a look at our 100 times our quality level for ordering, and we've got 96. So what's going to be left if we, after our shipment from the 96? Now we're left with just a little over 94. And so we do this again. And we see that only 89 orders out of 100 completed the entire process from order to delivery without any quality issues. And so another way we calculate this is to multiply each one. And this is another way of saying that essentially our ordering system from order to delivery is reaching only an 89.3% or 89.4% level of quality. So we aren't keeping our promise at a 95% service level. It's easy to assume that because our lowest level of quality is 95%, that we should be able to reach that. But as you can see, we lose some quality through each phase, which only allows us to make a promise of 89.4%. So the company, in this particular case, the company estimates a $500 loss for every sale after the 95% quality has been reached. And this could be lost sales from customers not returning, from having to, or costs from having to process the quality problem, whether it's processing a return or redelivering a particular product. So how far off are we from our target? Our target is 0.95. And we are only achieving a 0.89. We have a basically a 5% deficit from what our promise is. So if we had 10,000 orders last year, We're going to make this a little bit easier to read. So if we had 10,000 orders last year, then how many orders, or what's the volume of orders that did not meet the 95% expectation? So we're going to multiply that by our deficit. And we had 562 orders roughly that did not meet that 95% expectation. So if we're losing $500 for every order that didn't meet that 95% expectation, how much is our company actually losing? So we're losing roughly $281,200. Now, in some of my videos, you may have remember or recall me mentioning that sometimes it doesn't behoove us, or it's not cost effective for us to improve quality, and sometimes it is. In this case, we can implement a backup system for any departments that will reprocess 80% of the failed orders at that phase. So in other words, if an order does not pass the order phase or the ordering phase, that 0.4 or that 4% that doesn't pass can go through another backup check, and 80% of those will pass. So we calculate that. Let's put in our 0.80. So what we're saying in terms of ordering is that 0.96 plus we're going to send 1 minus 0.96, so the 4% of the orders, through another phase that is a 0.8 quality level. So what is the actual quality level for this particular department? Now we're achieving a 99% quality level in the ordering section simply by adding in another 8% or another 80% as a backup for that 4% that doesn't pass the ordering phase. So in this case, the company can implement this system for each department, but it costs $100,000 per department. Which departments, if any, should implement this system? Well, it's costing us $280,000. So if we implement it in all three, then we're going to be spending $300,000, which is greater than the cost of losing these orders. So in this case, we wouldn't want to implement them in all three, but let's take a look at if we can implement them in two and improve that quality level. So we're going to copy this formula over so that it's referencing these two here. And let's take a look at this. And then we're also going to copy this formula. So if we implemented it in all three, we would have a 0.978 level of quality. Much better. However, again, that's $300,000. We only have $280,000 in costs. So we want to take a look at which two would be best to implement this in. And we can do a little bit of trial and error, or we can take a look at where we're losing the most orders. And right off the bat, we're losing 4% here, and then we're losing another 2%, and then another 5%. So let's take a look at just taking out this middle piece. And certainly we can see now that we're above our 95%. We're at 96.2%. So we're not going to be absorbing any cost of being below 95%. And we're actually going to be saving $81,000 because it's only going to cost us $200,000, $100 for each of these two. Let's try just putting it in our last two. And you see we're below now this 95%. We certainly don't want to do that. So let's try the first two and double check that. And again, we're below 95%. So in this case, it's better for us to have a backup at the order and delivery, but we don't want to add one at shipment. Again, we don't want to strive for 100% quality. That is a target that is unachievable and actually demotivates employees. So we want to strive for the level of quality that maximizes profits, minimizes costs, and maximizes output for our customers. So just to sum up, the formula that we use is the primary plus the backup, which is multiplied times only the amount that's going through the backup. So it's 1 minus the primary times our backup. Each total is then multiplied by each other so that we can get our total system percentage. So I hope this has helped you better understand system reliability and how easy it is for us to make an assumption based off of individual component level of reliability rather than the entire system level of reliability.